Okay, we're done with 2.8. I'm going to start 2.9. And on page 155, it talks about the main reason for selecting a basis for a subspace H. The subspace, it's just a convenience thing for a subspace because the vectors that define it are more definable, and they're not as many, so you can find them easier, I guess. And then it's the definition of the basis is given here on 156, and then the x values that you take the vectors in the basis to find whatever the x value is defined by that little subscript x, the basis. So the values in this, that's C1, C2, and so on down to C whatever size it is just what you're taking the vectors that define the space by in order to get the x values. And they're going to go through a little example there of how the vectors that define the space and what that basis is, that basis vector. The dimension of a subspace on page 157, the dimension is going to be the number of vectors that define the subspace, and then it telling you that the zero subspace has the vector 0, and the definition of rank, and that's just the dimension of the column space. And if you remember, the column space for a matrix is a number of pivot points there are in the vectors that define the column space are the vectors in the original matrix for those pivot points. And then the theorem 14 is saying that the rank of A plus the dimension of the null space is equal to n. And the null space is always equal to the dimension of the null space is always equal to the number of free variables that you have when you are doing the echelon for a matrix. 15, that H is a subspace, and it says the p dimension subspace for any. So it's just telling you that the number of elements that have to be in each vector in the dimension of the subspace has to be the same as the number of rows that it is. And then there's the theorem there, the extension of that theorem 8 in section 2.3. So once again, if you have a square matrix n by n, and then the state that, and it's invertible, then the columns of A form the basis of Rn. And that's because if it's invertible, then you have this, you have n pivot points. And if you have n pivot points, then the columns, then the vectors, each vector in that space is going to be a basis for that matrix. And then it says the column of A equals R to N. The dimension of A is equal to N. That's because it has N independent vectors. Rank of A equals N. And the null of A, there are no free variables in that thing. So you'd have 0. And the dimension there is you have no elements or vectors in the null space. All right, so let's look on page 159. And number 2. It says find the vector x determined by the given coordinate vector xb and the given basis b. Illustrate your answer with a figure. So the basis is going to have these two vectors in it. And then x and they want to find x. So basically what you're having is you have this matrix minus 2, 1, 3, 1, and then you're multiplying it by that x, and you're going to get x. So what you would do this is essentially going to be a minus 1 times that first vector, because that doesn't write it out the way I've written it out. So this is going to be a minus 2 times a minus 1 plus 3 times 3, and then it's going to be a minus 1 times 1 plus 1 times 3. It's the same thing as if you would do a minus 1 times the vector 2, 1 plus 3 times the vector 3, 1. In either case, you're going to get this value right here. And because if you do it this way, then you would have a minus 1, 2, plus 3 times 3. And then you'd have a minus 1 times 1 plus 3 times 1. So this becomes the weight that you place on each vector. In any case, you're going to get your x value. So this is going to be 2 plus 9, 11, and minus 1 plus 3, 2. So your x vector is going to be 11, 2. So you can do it either one of these two ways. You can either write this thing out like this, multiply it and get this, or else you can just do weights and get it either way. It's going to get you to the 11, 2, and then they're saying show a graph of that thing. B1 was minus 2, 1. B2 is 3, 1. So B1 B1 is going to be a minus 2 and a plus 1, so it's going to be right there. And it went off on me. And then B2 is 3 and 1. So it's right up here. And then if you put the weights, if you put this weight on that vector, this is B1 vector, this is B2 vector. Then what you would do is you would take it back at 2 minus 1 right there. That's a little low. This is B1. This is a minus B1. And then 3 times B2 is going to be 3. So if I take 3 times B2, I get 9, 3. So I go out here at 9 and up to 3. So I'm supposed to just extend this on out. if I make this. Running out of stuff. This point right here should be 11, 2. So that's what it's doing, and that's what visual, I guess, vector of that would be. So, any questions on that? Okay, must mean either don't understand it or else. Okay, you understand it. 4. Maybe you can explain it to me. Do you understand? Okay, number 4 says the vector x is in the subspace H with the basis b, beta equals b1, b2. Find the beta coordinate vector for x. So number 4 says that b1 is equal to 1 minus 3. b2 is minus 3, 5. And x is minus 7, 5. And they want the beta, the x beta. So what you're actually doing is this. So you're trying to solve for this. So that's just do this matrix augmented with this and do an echelon of it. A reduced echelon, and that'll give you this vector, what you want. So that's what 1 minus 3 minus 3, 5, and augment it with a minus 7, 5. And then do reduced row echelon. So it's a 1 minus 3 minus 7. Multiply the first one by 3, so it's 0. 9 minus 4. And 3 times 21. So that's a minus 16. Did I do that right? Everything right? Looks like it. So I do 1 minus 3 minus 7. Well, let's get. I guess I'm gonna do it that way. Minus 3 minus 7. Divide the bottom row by minus 4. 1, 4. And then I'm going to eliminate this one, right? So I'm going to go 1. Now multiply the bottom row by 3. 12. 0, 1, 4. Now then, my x beta is 5, 4. Check it out. If I wanted to, I could go 5 times B1 plus 4 times B2, and it should give me my x. 5 times 1 minus 3 minus 3, 5. Get 5 minus 12 and minus 15 plus 20, which gives me, is that minus 7? Did it come out right? Yeah, minus 7, 5. So that's I'm going to do another one like it. 6. And I'm just going to do 3, 1, 4, 7, 5, minus 6, and then augment it with 11, 0, 7. Oh. I'm going to take that second row and put it in first. 1, 0. And I'm multiplying the first row by 3, so I get 0, 15, what's that, 22, and 11. And the first row by minus 4 is 0, and it's 26, and 7. Going to be the best way to do this. 0, and if I take 22 fifths negative, correct? No, I don't want to do that. I'll divide that thing by 22, so I'll get 1 and 1/2. Where's, you're talking back here in this first matrix?
Yeah.
First row bottom was what?
First row, no, first column, bottom row, it's negative, positive.
Okay. So how's that going to affect this next one?
No,
That one's not
For-
affected, then this
The
one's,
bottom row there,
okay.
14.
Okay, so I have to multiply that. I'm over here, this is a negative, right? This is a negative. So then I have to multiply the first row by positive 4. Is that right? So it's 0, 20, that's 14. So, now I can still do this, divide by 22 and get a half. Now I gotta go 14, so now I gotta go 0. And 14, so I do 14, negative 14, that's 0. And then this is 0, right? And now I gotta go second row times a minus 5. That's it, minus 5. So this is going to be a minus 5 halves. And then it's 0, 1, 1 half, 0 equals 0. So now my x beta is negative 1, 5 halves, and 1 half. So that should tell me that if I take 5 halves, negative 5 halves times my first vector, that's 4, and add 1 half of my second vector, 7, 5 minus 6. And I better get my 1107. Okay, so this is 15 halves plus 7 halves, and it's minus 5 halves plus 5 halves, and then plus 20 halves minus 6 halves. That's 22 halves, 0, and 14 halves. And this is 11, 0, and 7. And that's what my original thing was. So that's how you weight the vectors. Next one. Eight is saying let B1 equal 0, 2, B2 equal 2, 1, X is equal to a minus 2, 3, Y is equal to 2, 4, Z is equal to minus 1, minus 2.5. The beta is equal to B1, B2, and it says use the figure to estimate the X beta, Y beta, Z beta. Let's see, draw that thing out. saying this right here is B1. B1 is 0, 2. So that is B1. And B2 equals 2, 1. This is 2. So if we this is supposed to be the extension of the B2. And the extension of B1 is kind of straight up and down. So I'm gonna draw parallel lines here if I can. Ooh, not too parallel. Not too parallel. All right. And then they got X is right up here. And they got Y is right there. And then they got Z is down here. And we're supposed to estimate what the X beta will be. So the B1, it's going to be 2 for B1, and then a minus B2. Right? We should come back down to here, which is a minus B2, and then we should take this point and move it up here so that it intersects at X. This is X. the y we would go, b1 should be 1.5, right? And then 1 for b2. And then c beta. Z we would go the B1 we would go 0 B1 and then we would go a negative 0.5 B2, correct? That's what it should be. So if we take, to check it out, for xb1, for x, we should take, for b1, we should take 2 times b1 minus b2, and that should give us the x. So let's check out 2 times b1, 0, 2, minus b2, 2, 1. That'll give us a negative 2, and then it's 4 minus 1. Negative 2 and 3. Is that what x1 is? X1 is a negative 2, 3. So that'd be the weights that you give it. And then 1.5 B1 plus B2 should give me my y. So if I take 1.5, 0, 2 plus 2, 1, it gives me a 2 and 1.5, so this is going to be 3 plus 1, 2, 4, and my y was 2, 4. So this is x, this is y. Then my other weights are 0 times b1 plus, so minus 5 times b2 should give me my z. So 0 times 0, 2 minus 0.5 times 2, 1 should give me negative 1 and a negative 1/2. No. 0. I got that one wrong. Negative 1 and a negative 2.5. What was that? Z. Oh, I did. The Z I put in the wrong spot. Z is actually right here. So then that would be, this would have to be a minus. And then it's a negative 0.5. Then it, you'd still get minus 1, but then you get a minus 2.5. Okay, and that is the so it's just approaching it backwards. It's asking you to put the weights on by visually looking at it and then making sure that it comes out right. 9 through 12. It says display a matrix A in an echelon form of A. Those are the two things that are displayed. Yes, matrix A, echelon form of A. Find the basis, and they should have spelled, I don't know, they should have spelled that BASIS. They should have said displayed as a matrix A and an echelon form of A. And it says a basis. Find the basis for column A and null A, and state the dimensions of these subspaces. And then they're giving you this one. And when they want the column A, the way you do it is when you get it in echelon form, you find your pivot. That's a pivot, this is a pivot, and that's a pivot. And then they want the basis for that column A. And this is just one of the bases for column A, but you use this because it's convenient. Basis for column A. And what that is, you go right back up here, and that pivot column is from this vector, and that next pivot column is from this vector. And the third pivot column is from that vector. So the basis is the vector 1, 1, minus 2, 4, minus 2, minus 1, 0, 1, and 5, 5, 1, 1. So that's a basis for it. So the column, basis for the column, that's pretty easy to get. But then they want the basis for null A. What you're going to have to do then is you're going to have to take this thing to reduced row echelon form. And the number of free variables you're going to have in this thing are 2, right? Because you have 2 pivots or 3 pivots, and you've got the other 2 are going to be free variables. Okay. So I have to go along with this. So now I've got to go back up, and I'm going to take the third row and eliminate, put zeros above it. So that's 1 minus 2, 9, and I'm going to have to, that's a 5, isn't it? So I've got to multiply the third row by minus 5 to get a 0 here. Third row by minus 5 is like plus 10, so that makes that 14. And then it's 0, 1, minus 3, 0, minus 7, 0, 0, 1, and minus 2. Now I have to go to my second column, and I got to get a 0 of that 1. So then I'm going to go 1, and I have to multiply the second row by 2, 0. This is 3, 0, 2, 0, and it's 0, 1, 3, 0, minus 7. 0, 0, 1, minus 2. Now technically what I got is I got this AX equals 0. So I really augmented this thing with zeros. Okay. Now, what I'm multiplying it by, that x is 1 through 5, right? My x is actually x1, x2, x3, x4, x5. Because I got 5 columns, and when I multiply it out, I have to have 1 column, 5 rows in my x. So then the parametric equation for this is x1 plus x3 equals 0. The second row is x2 minus, I should have put a 3 in. This is 3x3 minus 3x3, and then minus 7x5 equals 0. The next one down is x4, isn't it? x4 minus 2x5 equals 0. And then x5 equals 0, right? So my parametric here, I'm going to get x1 equals a negative 3x3, x2 equals a negative 3x3 plus 7x5. X3 is a free, so it's just going to equal x3 x4 is equal to 2 x5. 2x5, and then x5 is and then what I have. What's that?
Yeah, just to make
Yeah, we do. I guess I can finish that.